Hello, everybody. This webcast on tooling management is brought to you by MAS, Manufacturing Asset Solutions, where our priority is to help you get the most out of your manufacturing assets. Hey, thanks for joining us. I'm Greg Fitch, and this webcast will provide you insights and solutions to three major tooling management problems. Now, we're going to be going through a lot of information today, so if you'd like a copy of this webcast or would like assistance in selecting a tooling management program, then we'd love to hear from you. If your tooling costs are out of control, or if your end product quality is suffering due to tooling problems, or even if your tooling planning isn't where you want it to be, we'll provide you solutions to these expensive and frustrating issues surrounding tooling management. If you're a company that is heavily invested in tooling, then you already know it can be challenging to strike the right balance with your tooling program. Tooling costs can amount to millions of dollars a year if poorly managed. For example, if you have too much tooling on hand, or if the tooling you have on hand is disappearing, or even if you are spending too much on tool purchases and repairs, it can be frustrating and costly. So how can your company get a handle on tooling costs? Let's start by identifying each tool storage location with a designated barcode so that it will be easier to read the storage code whenever a tool is checked in or out. Many companies know that a tool is in inventory, but they are unable to ascertain exactly where that tool is, whether it's being used in the shop floor, in storage, or if it's disappeared entirely. If possible, we recommend engraving tools with an asset number or affixing a barcode to a tool. But if you can't affix a barcode, for example, if the tool is subjected to various environmental conditions, then it'll be best to engrave the tool number or laser print the asset number on the tool. We should also identify tool users via barcode. So each employee, department, section, or machine that requires tools should be assigned a barcode number whenever that tool is issued to an employee, location, or even to a machine. Collect the barcode and user ID data. The fourth step we should do for barcode identification is to record all tool check-ins and check-outs. Many companies only track when a tool is first checked out. They may record the first user, but then the tool sits on the shop floor with no further identification of users or tracking for other projects or products that the tool is being used on. So, for each unique user, we should collect the barcode ID. Tooling should also be managed to track cost and depreciation data. Often, the purchase cost of the tool is known or can be identified. But after a while, companies have no idea what the tool is worth. Companies that have millions of dollars worth of tooling should first assign a purchase cost and a present value to the tool or a depreciated value. Tools are considered to be capital assets, so they can depreciate at 100% after 5 years. So if you have millions of dollars worth of tooling, that could be hundreds of thousands of dollars a year in write-offs that you could have against the tools. Set up a system that allows you to depreciate tools automatically, which will enhance tooling cost control. This also prevents the labor-intensive process of doing manual inventory counts each year to find out what tools you have and what they are worth. The other thing you need to do is to track quality, tooling repair costs, and scrap. Most companies that do repairs in-house don't track the labor or they don't track the scrap costs of the tool. If tools are sent outside for repair, companies generally have only a vague notion of how much it costs to repair a tool. Companies looking to reduce tooling costs need a proper system that tracks the repair and scrap work orders and allocates actual costs. Again, you can write off capital asset costs every year against the general income statement or against the project. Thirdly, we should assign each tool a unique ID number and differentiate perishable and non-perishable tools. Therefore, tools that are always in use and not expected to perish after one-time use should be identified with a unique ID. And if you have a quantity of 10, you should not put 10 under one ID. You should serialize them with a -1, -2, -3, etc. So you can track the individual tool, track the individual cost, track the individual repair costs and usage, and so on. You should also try to aggregate your tools into family codes. Now, family codes are basically tooling types. You need to assign a family code to tools of the same type, feature, and size. This way, if you're looking for a particular tool type or function, you can find out how many of that tool you have on hand. Let's say you have 10 tools of the same functionality and size. Now, you don't want to overuse one and have the other 9 sitting in inventory not being used, because that will tend to cause end product defects. So you want to be able to circulate these tools, and also you want to make sure you don't have too many or too few of them available. If you have too many, that will increase inventory costs, and if you have too few, it causes bottlenecks on the shop floor because the tools aren't available when they're needed. Thus, you need to differentiate between perishable, consumable tools and non-perishable, non-consumable tools. So basically, jigs, fixtures, and so on are non-perishable, non-consumable tools. But things like drill bits, sanding paper discs would be perishable, and you may elect to track them or you may elect not to track them. However, you should be able to distinguish those tools because over a period of time, they add to the annual costs, and in order to have a proper and effective tooling cost control, you need to track all the tools that are being used. Here, we are demonstrating a tool tracking software called ToolTrax version 6.0. On this screen, we show the minimum amount of data required to intelligently identify a tool. Most companies will have a tool number that is non-unique with some description and maybe a size. But the data shown here is that which is required to have a complete, working, and efficient system that will help you reduce your tooling costs. For example, you should at least have a unique tool ID to identify each tool. You should assign a purchase cost, and you should assign a detailed storage and user location to each tool or asset. This way you can track the individual tool, you can find out how much it costs, and therefore you can depreciate it. You can also easily find out where the tool is stored, who is using the tool, and what location the tool is being used. An intelligent and unique tool ID indicates tool usage just by reading the type of tool it is. So instead of giving the tool number of 1, 2, 3, 4, 5, 6 and then having to look up a description to figure out what tool number is, you can create your own intelligent tool ID. In this example, the tool number is MCSC2F01-1. MC stands for milling cutter. SC stands for solid carbide. 2F stands for two flutes. 01 stands for the size, which is 1 inch in diameter, and dash stands for 1 out of 10 tools in this example. Therefore, whenever you are looking for a tool, you don't need to know the actual tool numbers if you have an intelligent tool ID number. You can type MC and find all your milling cutters. You can type MCSC and find all your solid carbide milling cutters. You can search by 2F and it'll give you a list of those two-fluted tools. Therefore, it becomes easy for a user to identify a tool and locate that tool efficiently, just by looking up the tool number. You can group these tools into families so your family code will tell you how many of a certain type of tool you have in inventory. You can rotate them, find out which ones are available, and which ones are the most or least used, repair costs, and so on. As discussed earlier, if you record the purchase costs and you have a system that controls all your tooling inventory and has an asset depreciation module in it, then you'll be able to, with a stroke of a key, look at your total inventory and depreciate it annually. Now you'll need a system that allows you to depreciate your tooling by either percentage or fixed amount. As we mentioned earlier, you're allowed to depreciate a capital asset over 5 years, so the depreciation would be 20% each year. In this way, you can write off 20% of your tooling assets annually. So if your tooling is worth $10 million, it's $2 million in write-offs. Then of course, you'll need a system that can produce a complete record of your purchase costs and your annual depreciation in case you get audited. During the past 25 years, it has been our experience that most companies maintain a simple spreadsheet to list their tooling assets, or simply enter the tools into their material inventory database. Only major tools are usually identified with an engraved marker or barcode. Multiple tools of the same type are usually given the same tool number. There is usually no reference to the permanent tool storage locations or current usage locations. There is usually no way to identify where the tools are or those that are missing. There is no way to identify the individual tools that have broken down or unique tools that are causing end product defects. There is usually only a reference to the type of tool that is missing, causing defects or breakdown. Most companies do not use a family code to identify tool type, size, and features. There is no way to compare tools of the same family code to each other in order to determine how many there are in inventory, whether there are too many or too few in inventory, whether the tools are being circulated so that few aren't being used too often and breaking down while others are inactive and rarely used. Given all that missing data, there is no way to produce tooling inventory or the annual tooling purchase and repair costs. There is also no way to place a purchase moratorium on overstock tooling. Most companies do not differentiate between perishable, consumable tools and non-perishable, non-consumable tools. Perishable consumable tools are normally expensed at the current fiscal year, while non-perishable, non-consumable tools are considered a capital asset item, that is, depreciated over 3 to 5 years. Most companies do not take advantage of the considerable tax savings that can be achieved from depreciating the non-perishable tooling assets on an annual basis. And most companies do not track tool usage or collect user ID, work order number, or the operation number against which a tool is issued. Therefore, there is no way to assign tooling purchase and repair costs to the end user or end product. Is your end product quality suffering due to tooling problems? Well, the second tool management problem that many companies suffer from is end product quality. So if it seems like your tooling is always breaking down, or your end product scrap rate is going up, or if your tooling is always in repair, then let's look at how to address these issues. This is the second grouping of problems that having a solid tooling management system will help alleviate. Most companies have no real data on how their tools are really being used on the shop floor, so you need to assign a maximum allowable usage to each non-perishable tool and tool family code. That means you have to designate how many times you can use a tool. To do this, you need to set a limit on how many parts you can produce for the tool, or how many times the tool can go in and out to the shop floor. Based on this data, compare the allowable usage to the scrap rate. That will allow you to determine the optimum to maximum allowable tool usage. This should help you drastically reduce your end product scrap rate and drastically improve your product quality. Similarly, you should set a maximum allowable service time to each non-perishable tool and tool family code. So if you aren't tracking an actual number of parts that are being used, you can track the operational hours. This usually applies to electronic or electrical tools. Either track the maximum allowable usage or the maximum allowable service time. As a default, even though you have a max allowable usage and allowable service time, you should assign a default recall inspection date to each non-perishable tool and tool family code. This way, the tool will get inspected and may be on a periodic basis if it has not been used, and that could just be a visual inspection. But if the tool has been used, then the allowable usage and the allowable service time will kick in long before the recall date. This way, you can ensure all your tools are inspected, regardless if it's once a year or every 6 months. The other thing you need to do is withdraw inactive tools from inventory and place a purchase moratorium on inactive tools. So basically, if you implement a system to denote intelligent tool ID numbers and aggregate tools into family codes, then if you're tracking the usage of tools, you'll be able to determine if this tool is being overused or underused. If you find you have too many tools on hand and not enough usage, well, the first thing you can do is put a moratorium on and say, we will not be buying more of these tools, and maybe you can also sell some of the excess tools you have on hand. Next, we recommend to collect and record data and use the collected data to trace back the tooling used when end product defects start to appear. So if you find a defect in your end product with a quality tool management system, you'll be able to identify all the tools that were used on it, and using the collected data, you can determine the optimum tool usage life cycle and operation hours. You'll be able to tell how long the tool can be used on the shop floor and how many parts we can produce with it before we need to maintain it, repair it, sharpen it, or recall it. With this data, all the tool recall criteria will be based on the new and optimized tool life cycle. It's very important to collect and track work orders, job numbers, and operations against the specific tools that are used in case you find a defect or you have to scrap a part. You can trace back a part against where the tools were issued and against the work order and be able to take corrective action. Otherwise, if you don't have the traceability, you'll keep on having the same tooling issues, the same defect and scrap issues with no way to go back and correct the problem. You should also collect the number of parts produced with each tool. This is a good idea because when you first start, you have no idea how many parts you can produce with each tool. Then, at some point in time, in order to optimize the use of the tools, it'll be a good idea to record the number of parts being produced and finally increase tool inspections for active tools that will reduce inspection time for inactive tools. You'll use the data that you've collected to determine the maximum number of parts that can be produced with each tool before it breaks down. Use that collected data to determine the maximum number of operational hours that the tool can be used before the tool breaks down and rotate the usage of tools of the same type so that none are overused or underused. As previously discussed, each tool should be assigned a default repair or maintenance recall date, and each tool should be assigned either a maximum allowable usage or a maximum allowable service time. The tool management system that you use should at least be able to recall the tool based on either the default recall date or either maximum allowable usage or maximum allowable service time. And if you have those two criteria defined, then you'll be able to optimize your tools and you'll be able to determine your tool life cycle, track all of the end product defaults, and improve the end product quality. It is also important as a part of this effort to track the user location to which the tool is being issued and the user custodian. So in this example, the user location will be a machine or department that the tool is being issued to, and the user custodian can be the employee that actually took custody of the tools. You should also collect the work order number and the operation against which the tool is being used. This way you can trace the tools back to any defects or any end product quality issues. And in order to maximize the usage of your tools and make sure your tools don't sit on the floor unused, you should collect a due back date for each tool. This way your system will recall the tools that are due back, so if someone needs to use the tool for a date, the due back date will be adjusted from that point in time, and then the tool crib attendant will have a list of all the tools that were due back and then go out and collect them knowing that the job was done. This way the tools don't sit on the floor or go unused or get overused or get misplaced or just sit there. When you are checking a tool back into the tool crib, you should collect the added usage, be it how many times the tool was used, or how many parts it was used on, or how many parts it produced. So either the added usage or the added service time, which are operational hours of the tool, can be collected. At least one of these two criteria will help in determining the tool lifecycle and will help in improving your end product quality and reducing your end product scrap rate. It has been our experience that over 95% of companies do not have a maximum allowable usage limit or a maximum allowable operating hours limit for each tool or family of type of tools. Most companies do not track tool usage on the shop floor. They do not record the number of parts manufactured with each tool or the number of operational hours for each tool. Therefore, these companies cannot predetermine how long a tool can be used for or how many parts that can be manufactured with the tool before it breaks down, goes out of tolerance, or starts producing defective end products. It is critical that a company collects tool usage data and operational hours data in order to determine the tool usage life cycle. It is vital that a company develops a tool usage life cycle for each family or type of tool and for each individual tool. An optimized tool usage life cycle will allow the company to control and reduce end product defect rates and reduce tool breakdowns and repair activities. Most companies do not track work orders, job numbers, and operations against which the tools are issued. They also do not collect the number of parts produced with each tool. Therefore, it is not possible to trace back the tooling used when determining the causes of end product defects and improving end product quality. Most companies do not record all tool repairs, scrap, and maintenance activities. These activities must be recorded and included in the determination of the tool usage lifecycle. If these activities are recorded and analyzed, the result will be fewer tool breakdowns, fewer tool repairs, and tool scrap. Also, the company will be able to identify the tools that were not used and pull these tools out from inventory and no longer needlessly inspect and maintain them when they have been sitting idly and unused. Once an optimized tool usage lifecycle has been determined, the company can identify the overused and underused tools and ensure that underused tools are circulated more often and at least inspected less often than an overused tool. Also, underused tools can be withdrawn from inventory and a purchase moratorium placed on purchasing these types of tools. The third area of tooling management problems is the tool plan or lack thereof. Is it difficult to find tools when you need them? Are tools designated for jobs but unavailable when needed? Are tooling problems creating delays and bottlenecks on the shop floor? These are some of the most common problems with tool planning. You can never find the tools when you need them. You reserve tools for jobs through your ERP system only to find that they're not there, and these problems cause production delays on the shop floor. So, in addition to cost problems and quality problems, companies face major tooling planning problems that are very costly. There are a number of things you can do for a more efficient tool planning. Create a planning and reservation list. You can institute a tool planning and reservation system that can reserve tools based on family code, set number, end product number, operation number, or work order number. That is, if you are using an intelligent tool ID number and you have family codes or you have set numbers, then you can reserve the tools based on the jobs that you need them for. You don't need to reserve the actual tool, but you can reserve a tool from that family or a tool that is normally used for that end product number. Again, if you use the recommendations we've set forth earlier on, you'll be able to better plan your tools for jobs and reserve them ahead of time. So you need to institute a tool planning and reservation system that checks for current tool status, usage, service hours, and repair condition before planning and reserving the tool. That means you don't want a system that will just reserve a type of tool only to find out that tool isn't available. It's reached its maximum allowable usage, or it is in repair, or someone else is using it, or will be using it at that point in time. So you need a proper system that can tell you if a tool is available and if it's not available, and why it's not available, and suggest a replacement. The third thing you need is to interface the tool planning and reservation system with the ERP and shop floor planning modules so that you can download and validate the planned work orders, operations, and quantities. So basically, you need your tool planning system to be able to go into the ERP system whenever you're checking out tools and make sure that the tools are checked out, valid shop floor work orders, and valid operations or part numbers. To maintain data integrity, you don't want the users to check out tools against work orders that don't exist or operations that have not been planned. Of course, in the same way, whenever you're checking out tools against valid work orders and operations, you can pull down the quantities from the ERP system and check the data against them. To further increase tool control, you'll need to collect tool usage data. Provide tool crib personnel with real-time and online reports that list the reserved tooling and dates and locations to which the tools will be checked out and delivered. This way, the tool crib attendants can actually get an electronic request form for tooling ahead of time and then make sure the tooling is available and take it out to the user ahead of time. This way, you don't have extra personnel in the tool crib looking for missing tools. Proper planned jobs make sure the tools are available, but you can only do this if you have a system that will provide tool crib personnel with real data in real time and online. The other thing you need to do is to provide tool crib personnel with real time and online reports that list the tooling that is needed to be picked up once the work orders, operations, and jobs are completed. Also, you want your system to tell your tool crib attendant, okay, that tool is checked out against the work order, reproduce the part quantity, the tool did its job, now it's ready to be picked up. So the tool doesn't just sit there and is used for another job, and even though that tool is now due for maintenance, calibration, or repair, and then make sure the tool is available for another job, user, or end product number. And you need to check the tools back into the system and collect all the usage data when you check it in. So again, the tool crib personnel will be able to perform the quality control and have the opportunity to collect the tool usage and service times when checking in the tools. As you assign family codes to tools, you'll need common family codes for tools of the same type that can be used for the same job, or some common set numbers or kit numbers to the group of tools required to perform the specific operation or shop floor job. Therefore, you can take an end product and critically evaluate the tools you'll need. They could be tools of various types, but it will still be easy to identify the tooling required. You can give all these tools a common set number or kit number for efficiency. This way, you can pull out tooling based on what it's used for, the size or the function, or the resulting end product. One way to pull them out is by family code, or by set number, or kit number, or end product part number. You also want to allow the ERP modules to automatically reserve tools in the tooling management system using the tool family code or set number. So the ERP system doesn't need to be able to identify the unique tool that you need for the job, but to indicate to the user or the tool crib attendant what type of tool is required for the job based on family code, set number, kit number, or end product number. As we have indicated earlier, you should assign an intelligent family code or tool type to each non-perishable tool and assign a set number, kit number, or end product number to each tool. And we've discussed, if you're using the recommended set number, kit number, or family code, your tool planning system will be able to plan and reserve tooling using a set number, kit number, or end product number, or tool family code. It's easier if your tool crib attendant or your planning department reserves tools for jobs ahead of time. If you have a proper family code or properly set number, your system will be able to do a much better job at planning. So the tooling management system will be able to plan tools based on family codes or set numbers that they receive from the ERP system, and then pick the individual tool that will fulfill that requirement. Over the past 25 years, we have found it rare for a company to have in place a separate tool planning and reservation system. Most companies use an ERP system that plans jobs and work orders and can reference production machines and some large pieces of tooling on the shop floor planning schedules. Detailed lists of all required tooling are seldom available or even possible. Less than 5% of companies have a real-time, online system that allows users to reserve detailed lists of tools for jobs. In order to have an effective tool planning and reservation system functioning, a company needs to assign tools of the same type a common family code, assign non-similar tools that are required for a specific job, part numbers, or operation a common set number, and allow the user to plan and reserve tools using the family code and/or set numbers. The company would also need a tooling management system that can use the family code and set numbers for the requested tooling and determine which individual tool, with its own unique ID, is available for that planned job, and ensure that the tool is in good working condition and is not in use during the requested period on another job, and is not due for inspection and/or repair during the requested period. An effective system setup would require the tooling management system to interface with the ERP planning modules and allow the ERP modules to automatically reserve tools in the tooling management system using the tool family code and set numbers, and to provide the tool crib personnel with real-time and online reports that list the reserved tooling and dates and locations to which they need to be checked out and delivered. Also, provide tool crib personnel with real-time and online reports that list the tooling that needs to be picked up once the work orders, operations, and jobs are completed. The tooling management system must include a tool checkout and a tool check-in module that can collect the user, work order, operation, operational hours, tool usage, or quantity of parts produced. The system must be able to flag the user when planning tools and or checking out or checking in the tools that the maximum allowable usage and operational hours limit has been reached to prevent the user from further transacting the individual tool. Such a system setup would eliminate any existing bottlenecks or delays on the shop floor caused by tooling problems. Then, if you would like our consultants to take a look at your system and make recommendations, contact us at one of the following websites, emails, or phone numbers. Hey, we know there's a lot more to consider, so we hope that you'll contact us. And thank you for your attendance at this MAS presentation.